All right, so ready for Unit 3, Lesson 3, Explore, Multiply and Divide Expressions Using Scientific Notation and Exponential Properties. Okay. Skill 1, convert standard notation into scientific notation and then back again. Okay. Scientific notation is used to represent very large numbers or very small numbers. Sometimes standard form is referred to as decimal form. It's just terminology there. Standard form is what we're used to. If they have a big number, it's got lots of zeros and commas, and these are big numbers. These are super small numbers. Okay. And it's just impractical to use all those zeros. You can get that wrong and count them wrong and that kind of thing. So they invented scientific notation with the base 10 as an exponent to count how many zeros. All right, so in this big, huge number for the speed of light, where's the decimal point now? The decimal point is right here. You don't really see the decimal point, but it's right here, okay? And if you count how many zeros, go 1, 2, 3, 4, 5, 6, 7, 8, to put the decimal after the 9 where it is here, we went 8 hops to get there, okay? So scientific notation has this number here times 10 to the n power. So whatever number of hops you made to get the decimal with one number on the left side. All right, so even though this is 983 and then a whole ton of zeros, we counted all the zeros. There were 6 zeros, plus we need to move it 2 more places to get to only have one number right there. Okay, sorry about all the underlining and arrows and all that stuff. Hang on, let me do that again. Right, this is bothering me up here too. Okay, let's try that again. This big number here, okay, has 6 zeros, and then the number parts are here, right? They have 6 zeros, and when you're counting across, 6, 7, 8 gets you to where the decimal has to go to represent not scientific notation. So 6 zeros and 2 more places gets you 10 to the 8th power. Okay, look at this one. This one, the zero is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 to get it here, to have one number on the left side, okay, plus everything else. So when I went that way, it was negative 12. It's a super small number, okay? So these are for large numbers, is a positive exponent. And for very small numbers, you have a negative exponent, okay? So when you're So step 1 is to move the decimal so that A is greater than 1 and less than 10. Greater than 1 and less than 10. In other words, we need one digit on the left side of the 0. Okay? And then you kind of cut off all these extra zeros that are after or before. Okay? Then you count how many places you're moving the decimal to make it the exponent base 10, okay? And decide on the sign of the exponent. Move the decimal to the left, and n is positive. Move for large numbers, move it to the right, n is negative for small numbers. This n is what they're talking about right there, okay? And then put an x between the number and 10. This x right here, okay? That's just that number times 10 to the whatever power is what they're talking about. So, for example, 342,000 is in standard form. That's how we recognize it, right? Everyday form. The decimal right here is currently unseen at the end of the number. It's right there. That's decimal form, okay? Decimal, you can even, there's even zeros on that side of the decimal that you don't see. Okay, so this in fact are zeros that you don't see. Okay, not ones, but zeros. So that makes sense, I know. All right, so to turn this into scientific notation, you want to go 1, 2, 3, 4, 5 to move it to having just one digit, one number on the left side. So we moved it 5 times and lopped off all the extra zeros on the end. Okay, so n is 5 because we hop 5 times. So this is going to turn into this number right here. That's from standard to scientific notation. For standard form, the commas can be added every 3 numbers to aid in the proper counting of zeros or naming of the number. They do not count as a decimal. Okay, so whether this number is like this and has a comma in it, whether it doesn't matter on the counting. Okay. And if you had to go back the other way, if an exponent is too large, let's see, what is this for? Oh, scientific back. Okay, just multiply in the calculator. If your calculator will do it, do 3.42 times 10 to the, raise that to the, some of you have to go to the 7th power. 3.42 times 10 to the 7th power. And it should give you this really big number without the commas, okay? I use the commas to make sure I'm kind of counting right. So let's make sure. And let's say if you don't use your calculator either, let's practice just in case. What if that was like to the 27th? You're not going to be able to see it in your calculator, so we got to be able to count. So the decimal is here right now. 1, 2, 3, 4, 5, 6, 7 gets you to over there. So if it's over there and you count back by 3s, if it's over here and you're like 1, 2, 3, 1, 2, 3, okay, that's 34,200,000, right? So if the exponent is negative, you have to go back the other way. So when I say back the other way, look at this. This is 3.42 times 10 to the negative 4. So that means the decimal's here now. 1, 2, 3, 4 puts it back over here. And that's really what that decimal is. So when it says to the negative, you're moving it to the left. I remember it as it's a negative exponent. I want to end up with a really small number. Right, 0.0000 something. If it ends in a positive exponent, I want thousands and thousands of things on this side. Okay, bigger numbers, positive. Little numbers, negative. Most of the time, the extra 0 is added to emphasize where the decimal is located. It's not required, but it's a good idea. Okay, so this is in standard form right now, so the decimal's here. 1, 2, 3, 4. Move it to 1.42. Keep all the numbers, all the digits that aren't 0. Get rid of the extras, and then how many did I count? I went 1, 2, 3, 4, and I went and made it was a big number, so I'm going to leave it positive. Okay? This one over here, 1, 2, 3, 4.2 times 10 to the 3rd, but it was a little tiny number, so it was 10 to the negative 3rd. I'm not good with the right or left. If you can remember that, great, but I just kind of went big number, positive, little number of negative, okay? 3, okay, and then back the other way, 3.21, that's a positive 5. So let me move that over a little bit, so I got room. Ooh. 3.21. That's a positive 5. 1, 2, 3, 4, 5. That's where that dot should go. Put zeros back in the holes So 331100, and then I kind of go like this, so I can tell this is 321,000. Okay. You could probably try that one in your calculator. 3.21 times 10 raised to the 5th power should give you that number. If the number you're raising it to is too big, the calculator will put it back in scientific notation. So make sure you know how to count the small ones, all right? 7.4, I don't know if your calculator will do, I don't have my other calculator with me, we'll do negative exponents, but if you can do that, but otherwise you certainly should know how to do it by hand. Anyway, 7.4 to the negative third means we're going to make it a really small number. 1, 2, 3. We're going to hop 3 times, fill in the zeros, so 0.0074. Yeah, that's a little tiny number. It was here. 1, 2, 3. Yep. Okay. Oh, wait. I think there's another. Yeah, there's a whole other page. Sorry about that. All right, let's see. All right, so now we're going to use this information. So it says performing basic operations such as multiplying, dividing, very large and very small numbers can be cumbersome. So they changed it to convert it to scientific notation so they can make it easier to do them. So you, step 1, multiply or divide the front numbers first. That's the A part. Okay, if the result does not have a 1 digit in front, convert your results to scientific notation. Step 2, use the exponential properties to simplify the hundreds, then put together. Okay, so let's do one of these. All right, so this is the A part, and that's the, and I'm not going to quiz you on this, but if they're going to refer to it in the instructions, I need to say that's the A part for this one. The N is a negative 7. Okay, let's just be really clear about those. And then the other one, the A part is 3.71, and the N part is a positive 5. All right, so it says multiply the front numbers, or the A's, first. So 2.1 times 3.7 is apparently 7.77. I should probably be checking these numbers to make sure they're right. Let me get my calculator. 2.1 times 3.7. Yep. All right, 7. The result has 1 digit 7 in front of the decimal. So we're good. All right, we're trying to turn this, remember, into back to scientific notation. We're multiplying two terms that are scientific notation form, that are in scientific notation form, and then multiply them and turn them back into scientific notation. So we're okay having the 1 decimal. That's going to be what we want at the end. Sometimes that'll come up to 2. We'll do one like that. And then you multiply the bases like we've been doing. That's why it's in this section. You have a negative 10 to the negative 7 plus 5 gives you 10 to the negative 2, and then you just plop them together, and that's the new number that you get. Okay? Where it gets complicated is when you multiply the front two numbers and you get something that is not in scientific notation already. So you need to convert the 28.67 into scientific notation. You move this decimal one place. It was a big number. All right. And then you add that in when you're multiplying across with the bases. So this one has a negative 3. This one was to the 9th. So negative 3 plus 9 plus 1. That's 10 minus 3 is 7. Okay. So that's why our final answer is this. Okay. So if you don't end up with one place, you have to convert it and then put them all together. Okay, I find that to be the easiest to do. There are certainly other ways to do that. this is my recommendation. All right, when we're dividing, we're doing the same thing. We are dividing the front numbers of the A part. Okay, so this is 2.014 divided by 3.8. That comes out to something that's not scientific notation. It doesn't have it in one decimal form. So we need to convert this by moving this decimal one place, and it's a small number, so that's a negative. Okay, so back up here we have 10 to the negative 1 plus our 10 to the negative, 10 to the negative 3 plus our 10 to the negative 1 divided by 10 to the negative 7. So let's be careful with that. So this is 10 to the negative 3 minus 1 minus a minus 7. I know, that's a little crazy. 3 minus 1 plus 7. This is minus 4 plus 7. This is a positive 3. All that mess turns into positive. If you want, you can 10 to the negative 3 plus a negative 1 is 10 to the negative 4 over 10 to the negative 7. And then some people just kind of swap them and then reduce, but that seems like a lot of work too. But it does all work. There's a lot of different ways to solve that, okay? But the bottom line is it's going to be 10 to the third, and we fix this number here, so it's this number, and that's our final answer. Okay?